So you can see the stream, no?
Yes, sir.
Okay. And so we have already discussed about these points, the control structure, sequence, selection, and repetition. Then after discussing that, then we have discussed the examples. Sequence means the steps. It's like steps, one after the another. So going from school from grade 1 to grade 11. And selection is like you select your A-level subjects, and it's like junction, and the repetition is like repeating the same things like roundabout. You repeat the same thing till until a certain condition satisfied. It's not, but roundabout you go one time basically. Anyway, it's like okay, if it is related to traffic, it's like maybe what's like in traffic. It's like a bus route. You go through the same path again and again until the day ends. You go a few times in the same path. That's repetition, right?
Yes.
Okay, then we learn how to represent the algorithms using these symbols, and I said that connector is not a compulsory component. Why connector is not compulsory? In your book also they have ignored the connector. Here this is sequence to find the radius of the circle, and here this is selection to find whether the number is odd or even. Here they should include the connector, but they have ignored that. Therefore you can also ignore in your examination. It's not compulsory to have the connector, but it is better to have the connector uh, as it's meaningful. Then without connector also it's okay. And repetition, you have arrows following the same path, same direction here. So arrows moving down and then going up and moving down and going up. Likewise, it's same selection symbol, same decision symbol, but only difference in the sequence and selection. So the selection and repetition is here you have these arrows are not going in the same path. It's not going, not moving in the same direction, basically, not focusing the same direction here. Here this go this side, and with the other arrows that go the other side. But here you can see all arrows are going on the same direction like a loop. Okay, how we represent selection? How we represent selection in Pascal? What are the mechanisms to represent selection in Pascal? Yes. Look at the code. Selection. One is if else, no? We learned that. One is if else.
Yeah.
There's another one that is called switch case. Second one is switch case. Did we learn switch case or only if else?
So only if else.
All right. Okay. Today we'll study switch case part 2. Okay. The next one. How to represent repetition? How to represent repetition in coding? How to write repetition in coding? Pascal? Yes, we learned that. Those are loops. Can you name the loops?
Do while.
Do while loop, and the next one is for loop, and the next one is repeat until. You have 3 loops to represent. So let's go through the coding and confirm what you have learned. So we discuss, I think, 1 or 2. I think we discuss while only, no? Do while?
Yes.
Or for also? While and for both?
Oh, also?
Yeah.
We didn't discuss the last one.
Yeah, repeat until. Okay.
Repeat.
Yes, let's move. And there are some examples given, and we also did some examples. And the next thing is here, this is converting flowcharts to the pseudocodes. Here they have used a while loop. So begin, and so you can write like sentences, but it is not very good. But still, they have given marks in the examination, even if you don't write the mathematical equation, and if you write the sentence like thing, still the step is clear, they have given the marks. Okay, then this one you can see this is not a loop here. Go in both direction means if else. Here also going here going same direction means a loop, while loop. Go in same direction means a while loop or do while loop or for loop. But here going two directions means if else. Right? That's how you find, right? Easiest way to find out whether you have to use if else or while. Here which one? This one? Can you tell? Do you have if else or do while or what? Loops or both? This one is to basically find in the smallest number from 10 input. 10 inputs, find in the smallest number. Can you write the pseudocode? Without looking at the book, can you write? Yeah.
Both.
Both are there, yes. Can you write it? I better if you can write it. Without looking at the book, try to write this.
Okay.
Can you tell the one that you have written?
So I wrote begin.
Begin.
And then
Okay.
input number as n.
And let's say input n.
And then min equal n.
Mean equal n. Okay.
Count equal 1.
Same thing that basically you have to write the same thing. Okay, count equal 1 because it is sequence. In sequence, nothing to worry. So sequence, the initial part is sequence. Input n, min n count 1. Min equal n, no? Min equal 1 or min equal n? Min equal n. Which one you wrote min equal n or min equal 1? Hello?
So I wrote min equal n.
Oh, min equal n, right, okay. Then count equal 1.
Then while count less than 10.
While count less than 10.
In next line, input n.
Inside while. So you have to do, right? Inside do input n.
And then if n less than min.
If less than min, then
min equal n.
Then min equal n. Okay.
And then end if. And then count equal count plus 1.
And end the while.
And while, and then print n and end.
Print n.
End.
And then. Yeah, correct. Did you discuss this earlier? This one?
So we did
Similar.
not this the same thing, but min and max both we did it.
Min and max both we did, right? Okay, so it's so basically that's why I said that these are typical examination questions. So basically this is how you write, right? So when you see this start input and this is sequence part, you write the same. When you have repetition, you write the while, and inside whatever inside this repetition chain. So here this is a repetition loop, no? This is the looping part, no? Inside the looping part, you have to write that part. 1, 2, 3, 4 things inside the looping part. Here 1, 2, 3, 4 things, and if you have this if kind of thing, you have to put that an end if. That is the additional line. This fifth line is end if, basically. So input n is there, then n less than this condition is there. So with the condition you will have end if. So it is one line, and then you have this one. If it is yes, min equal n. If it is no, count or no and yes both, then count equal count plus one, and end the while means you are coming this point, and after that you print or output n and n. So this one we discussed actually. So but the thing is, it's very easy to convert. Here you can see the answer, same. I think now you can write the code, no? It's okay. So you can,
Yes.
so this is short version, right? You can say input n, or for more meaning is there when input number as n, then it carry more meaning, right? Input number, that one you said number as n, that is also okay. Here this is wrong. In the book, did you notice that?
Yeah.
Yeah, it is also
No.
input n, no? It is also inputted.
Yes.
It says output number as n, but that is not. That is input number as n. So please make sure that this part you have to correct that. Otherwise, when you are studying for the exam, sometimes if you see this in the book, here this word should be input, right?
Okay.
Input number as n. There can be printing mistakes and all. That's you common. So not intended error, kind of printing mistake. And while and yeah, and while. So they used to write end while as a single statement or which space? As a single thing, right? But it depends. It's okay. And then, so Pascal, how to convert? So this one we did it, no? No need to do this again. So can you remember the Pascal code? Without using Pascal, can you tell me? Or with using Pascal, can you tell me the code? So quickly. So what are the variables that you have? N.
N
N.
mean
Mean is also there. N and mean both are integers. What else? And after
so
that,
count is no, right?
count. Yes, count is also there. And min and count both are integers. All three are integers. Then here, first of all, you have to input right, maybe enter number.
The number.
Then you can say read it to the number n, and then you can say what is this min equal
Mean equal
the 10.
n.
Okay, so then
Count equal 1.
count equal 1 because you have already input one number, and then you can say while
Count less than 10.
10 do what to do, and what to do inside this input. You have to input 10, that means this part again comes.
Yeah.
Write and read that n, and after reading you have to check if whether this
Less
number,
than.
yeah, if this n is even less than the current minimum. If it is even less than the current minimum, then you have to change the minimum.
Mean equal n.
Yeah. Min equal n. Okay, then if not, so this is end if pass. You don't need to write that, right? End if, because yeah. Then after that, count
Equal count plus 1.
count equal count plus 1. I think we skipped end if, no? If එක end if එකක් දානවද අපි නෑනේ සාමාන්‍යයෙන්. So if you have multiple statements, or not multiple statement, if you have like if else and all, then we put, otherwise we can skip that. So count is equal to count plus 1. Then after finishing the while, this is end of the while,
Print
right? End of the while. After finishing the while, that what you can do. You can print.
yes, print n.
Minimum is, let's give a message. Minimum is, then print.
N.
That's all, right? Let's run this. If there are no errors, it will start running. Yeah, no errors, it will start running. Number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it will give minimum is 76. Is it correct? No, no, no.
No.
Where we missed? If minimum is some error somewhere. Can you tell me? It is taking all 10 numbers. That is correct. But I think this comparison minimum less than n less than the minimum. If n less than the minimum, you are changing the minimum to n. That is correct. Okay. This was the one we wrote last day, no?
Yes, sir.
Check with the code that we have done. Let me check with the code. So maybe we have done small mistake somewhere. Not this one. Is this the one? No, not this one. If n less than the minimum, then minimum is n. The logic is correct. But what's happening? Initially, we have given 34. It's changing. So it's changing and changing. Minimum is not n, no. Minimum is me. Silly mistake. Understood?
Yes, sir.
Okay, that's why I said so. Logic is correct, but mistake is silly. Right, okay. So then you can print the numbers. Otherwise, it will print the last number. Some numbers and another number. Okay. Another number. Okay, now can minimum is 23. 23 is here. This one. This is the minimum. Correct, no? Okay. So if you wish, you can write this code, but I think you know this. So it's simple.
Yeah.
Right? Now, I think now writing programs, it's not a big thing now, no, it's easy. So if you know the flowchart and if you can draw the pseudocodes, so you can write the program easily. So writing program is not difficult. It is only thing is syntactically it needs to be correct. That is the only issue. Other than that, no any issues because if you have proper pseudocode and proper flowchart, the code will be correct automatically. Right. So this part actually, this much I didn't saw in the exam. They are not asking you to write the code, but sometimes they might ask you to understand the code. Maybe small piece of code they might give, but pseudocode and flowchart they will give, right?
Yes.
Okay, let's take a screenshot of this and let's add it to the sheet. Okay. And the next thing. Okay. The next thing is basically So these Pascal identifiers actually, so why now you can see why I did Pascal with flowchart pseudocode all three together. So now this is not challenging to you because no need to start from the beginning, right? We learned that the identifier need to be started with a simple or capital letter, and underscore is permitted and should start with the English letter, and underscore is permitted, and special characters are restricted. So you can't use special symbols, no spaces between words, right? And it is case sensitive. So it's basically in Pascal, it's not case sensitive. Basically, you can write art and art will be the same, but in some other languages, it's different, right? So this is not case sensitive, not like the other language, it's not case sensitive here. Not case sensitive means this one you can just go and write like n, and this one you can say min, simple, but still it should work. So here still it's working. So you can write simple n, simple mean capital N, but as a practice, maintain the same coherence. That means if you use capital N, please use capital N here, and all the places, please try to use the same thing. But it is not compulsory. But why I am asking you to maintain the coherence if you learn some other language, it is very important because most of the other languages are case sensitive, right? But in case in the exam, if they ask, will this give an error? No, it will not give an error. You can use simple N in some place and capital N in some place, all are same. Examination purpose, it's remember that, but when you are practicing, please try to use same case because most of other languages are case sensitive. Okay.
Yes, sir.
Then should not have spaces, and special symbols like these symbols should be ignored. These are invalid. And then they have given some valid identifier and invalid because this dollar sign and space and this number and this special symbol, those are right. Then the reserved word, you can't use reserved word for variable name or identifier name. Don't use reserved word. These are the reserved words. Okay, then standard data types in Pascal, we discuss integers or the numbers and reals. Reals means these decimal numbers. Integers means plus or minus numbers, the whole numbers, and plus or minus whole numbers are integers, and the plus or minus decimal numbers are real, and Boolean means true, false. Character means a single character, and string means a set of characters. Okay, then so what is a variable? We discuss about that. And what is an operator? Yes, we discussed these operators. So what's the difference between division and modulus? Yes.
Modulus is like the remaining after you
Yeah,
divide.
after remaining.
And
So division is what is the integer answer, and modulus is what is the integer remainder. For an example, if you divide 20 by 6, you have 3 sixes, 3 6 for 20, right? So that is called the division, and remaining part is called modulus. And these are the comparison operators, and we have not used the not equal one yet. Right? Not equal one yet, but if you want, you can use not equal one to compare. So we have used these things, right? Greater than, or equal, less than. Not equal, we have not used, but you can say not equal, where is possible to use not equal. Okay, so for an example, if you want to find out a special person out of set of students, right? So you can ask them to enter the student number, but if it is not equal, so if you want to block a particular student, so all other numbers allowed, but this if there's a number, so that number can be blocked. For an example, this. So assume that. So let me write a code like this. and I'm going to get student number. I'm going to get student number. Let me edit this. I'm going to get student number. Let's say STN. And this STN I'm going to read. And then I'm going to mention like this, while STN not equal, let's say student number 2030 is not allowed. Right? While STN is not equal, so you can use the not equal symbol, this one. While STN is not equal this, do write allowed. And you can maintain, no need to maintain a count even. While this is not equal to do, it's allowed. And then you can say, after ending the while, so this will end the while when it finds 2030, right? Let's say found the student. Found the student, and I'm going to write STN. So this program is basically to find a student with the student number 2030. So that means this, let's say this is like a police barrier. So you are checking for someone and you want to find this guy. You're searching for someone, CID or some. You're searching for this number, and if it is not the particular number, you allow all these people to go in. But if you found this, you will stop. So let me write the code. This is endless, right? This is endless. You can't tell start in place or end in place.
Yeah.
Right?
Yes.
Let's enter a number. I'm entering 23. So it's say allowed, it's going on. It's because so I have to display this one time, right? Not many times. So let's just this is going on. I have to enter the next number then. Otherwise, this is not ending. No? After going through this, it's allowed, and then try to get the next number. I have to stop. This is not never ending. Otherwise, let me copy the code. Refresh. I have to wait till the next input. Otherwise, it's mistake in my code. After allowing, I have to get the next number and check it again. I'll get the next number and check it again. Otherwise, what will happen? Otherwise, it will just print. And next, check the next number, and this next number, I have to check them. So let's write this now. So it will first check the number. I'm giving 23, allowed, and go to the next line, right? Let's write 34, allowed, 56, allowed, 89, allowed, 20, 12, allowed, 20, 30, found the student. Understood?
Yes.
So likewise, this is never ending, never end till you find the student. And maybe you can create a small game like guess the number.
Yeah.
Guess the number. So you have to, maybe you can say numbers in between 1 and 100. So if you guess the number, how many attempts you take to guess the number?
Yeah.
Right? So you can hide the code from your friends. So let's say number is between found the number. You ask your friend to, so hide the code, right? Hide the code and then run the code. And you ask the friend to guess the number. He's guessing 45. It's not the number. No, not. So you have to tell not the number, right? Not allowed. It's not the one. Try again or something. So then if you found the correct number, so you can maintain attempts here. Attempts.
No, sir.
Sorry?
No, sir.
Attempts. And here in the attempts, what you can do is this here, you can say initially attempts equal 1 when you insert the first number. Attempts equal 1. And when you enter another number, you can say attempts equal attempts plus 1. So here you can say write a line, try again. Now this again. Likewise, you can think of doing many changes. Right? Now assume that your friend cannot see the code and he's running the code. And the first attempt, he's trying to get the number. No, try again. No, try again. Yes, found the number. So you can display the number of attempts even.
Yeah.
Right? At the end of the code, you can display the number of attempts. Likewise, maybe in exam, maybe in exhibition or something, number of attempts and equal to attempts. So the least number of attempts, those who write this number with least number of attempts can be the winner.
Yeah.
So likewise, you can think of the questions that are going to come in your examination, right? So without waiting for them, you can generate, you can think and write different cases. So this can be examination question. Right?
Yes.
So we try to use not equal, and it has given our so when you have this kind of things, equal or not equal, so you can generate like never ending loops. You don't know number of attempts, but it continues till a certain condition achieved. Right? Here, if it is not equal, it continue. But if it is equal, it stop. If it is equal, it stops. Okay, let's move. Logical operators. Right? These are comparison operators. Logical operators means you can use AND to compare two conditions, and to compare two conditions, or to compare to O and O, or to compare multiple conditions. You know, if you have AND operator, AND will give, if both conditions are true only, AND will produce true. Logic gates, I think you have learned this, the logic gates. Hello?
Yes, sir.
Can you remember the logics?
Yeah.
So what is the specialty of AND gate?
AND gate is
It will output,
like only one can be true.
it will output true if and only if
Both
all
of them.
inputs are true. Just remember this status. Then that's really useful. Or it will output false only if all inputs are false. So in the other way, you can write like this, right? It will output 1 if all inputs are 1. Here this one, it will output 0 if all inputs are 0. So please remember these two statements, very important, and not will invert. Not will invert. 1 will become 0 and 0 will become 1. Okay, then assume that you get a truth table like this. Okay, you get a truth table like this. Yeah, this kind of truth table. If there's a rain, and then there's no if there's a rain and then let's say no light, so this is the output. So when there's a rain is there and no light, yes, output is not ringing. This is about alarm, right? If there's rain, yes. If there is no light, no, then it's ringing. If there's no rain, no light, not ringing. And if there's no light, so if there's no rain, light, not ringing. So this alarm will ring only if you have rain and no light is no. Right? If there is, that means if there is rain and if there is a light, then this will ring. Okay, can you draw a truth table? Can you draw a logic circuit for this?
Yes.
So how to draw a logic circuit for this? Quickly drawing. Wegin adinne kohama. Right? So there are two sensors. Sensor 1. So assume that the sensors are given. Sensor 1, it will output true when rain. Sensor 2, let's say it's let's give some names. Sensor 1 is X and sensor 2 is Y. Sensor 2 output 1, output true or 1. True or 1 when it is dark. So sensor 1, X will output 1 when it is rain. So sensor 2 will output 1 when it is dark. When you have light, so it's very easy to draw this kind of truth table or the logic circuit, because you know when there is a rain, that means X is true, and when it is dark, when it is not dark. Not dark means when it is dark, it is 1. When it is not dark means why not? So this is the circuit you have to come up with, X and Y not, because you know out of all, it's working in one situation. Out of all outputs, it's working in one situation. So such gate, you have AND gate. AND gate will output when both inputs are 1. If X and Y both 1, it will output 1. Agree?
Yes.
So here this is 1 and this is 1, it will output 1. But the second one is not 1, no? Second one is 1 when only no light. No light tibbot ekene. Dark unot tama meka. So remember this is confusing, right? So no light kiyanne mokada? No light nan tama meka 1 wenne me. no light නම් තමයි මේක 1 වෙන්නේ. හැබැයි මේක no light නම් මෙතන 0 නේ. Here.
Oh.
No light no කියන්නේ it's light. No light no කියන්නේ it's light. When there's light it's 0 no.
Oh.
Right? When there's light it's 0. Sorry. The other one, right? Other way. So x and y, if both are 1, it will output 1. So here you have to check whether, yes, if it is rain, this is 1. If it is no light, this is 1. This is also 1.
1.
Right? If it is no light, no means if there's light, this is 0.
0.
And this is also 0. Then you need the output when this is 1 and when this is 0. This should be 1. 1 0 1. Then you have to write. So 1 then a gate here. This is the one producing. The AND gate will produce 1. So AND gate will produce 1 when both are 1. But here both are not 1. This is 1 and this is 0. The 0 1 you have to make it 1 by making it not. Then x and y not is 1. So this is how you find the easiest way using this logic. Understood?
Yes, sir.
Right? So if you are using OR gate, how to find?
X plus y equal 1.
Yeah, here not ring in means 0. Not ring in means 0. Not ring in means 0. Right? 3 places you have 0 here. 3 places you have 0. So here you have to take all these 3 places. If you are using OR gate to create this gate, you have to take all 3 zeros. The first 0 is when this is 1. No is 0. No? First 0 is when this is 1 1 1 1 when I got a 0 then if both inputs are 1, how to make 0? You have to say x naught or y naught.
Not equals.
Yeah, x naught or y naught. Both inputs are 1, then it's 0. And so not just that. The second one 0 0, that is naturally 0, right? That means x or y, that is naturally 0. And the next one is when x is 0, that is good. When x is 0 and y is not 0. Here you have to make this one a 0. So this is equivalent to x and y not. So both gates are producing the same thing. So you can think in both ways, right? You can think from the 0 side or you can think from one side. One side එකෙන් ගත්තොත් AND gate එක දැම්මම ඇති. එතකොට AND gate එකයි ඕන වෙන්නේ. You will need only one AND gate. මොකද one side වලින් දැම්මම එක 1 එකයිනේ තියෙන්නේ output එකේ. එහෙනම් AND gate එකයි. OR gate වලින් හදනවා OR gate කීයක් ඕන වෙනවද? 1 2 3 OR gates.
3.
Understood?
Yes.
Right. So for a one example, you have 2 solutions. One using O, one using N. Okay, if there are something like this, so can you tell me, if there's something like this, can you tell me the circuits, the valid circuits? Now, think about 0, what are the valid circuits?
X and y not equal.
Yeah, x naught or and
Y
not
not.
n, right? X naught or y naught. That is from the first one. X naught, y naught. And the next one, not just that, no. There's another 0. That is x or
y
not. X or y not. Here, this one.
Yes.
You get it or not? If you not understand, please tell me. Right? This is one circuit. The second circuit. Second circuit. Using 1. 1 means AND logic. Using 1. Can you tell me the second circuit?
X and Why not
Okay, why not?
equal 1
Okay.
and
This one, you have to use O, right? This time because you are
yes.
either this one or this one, right? Then
Oh, x not
X not
and y not.
and why not? X not and why not. So these are the two circuits.
Yes.
Or AND circuit, if you are building AND circuit, you have to, in between these AND terms, you have to put plus, right? In between the AND terms, you have to put plus if you're trading AND circuit. If you're trading OR circuit, in between in between these OR terms, you have to put AND. Right?
Yes.
This has actually, this has a name. I didn't mention that. This is called product of sums format. The second format is called sum of products. This is called product of sums format. This is there in mathematics also. Why? Product means this dot of sums. Here you have two sums. You take the product of those sums. The second one, you have sum of these products. Products means multiplication like thing. Right? These are the two formats. If you want, please write down. There are two formats. So if you get the truth table, that means your circuit should be correct. Truth table එක හරියට ආවම circuit එක වරදින්න කොහෙත්ම විදියක් නැහැ, because there are two fundamental ways to create circuits using AND and OR gates. This is valid. Right, let me give some other examples. This is another lesson, but I just want to make sure you have correct theoretical knowledge to do this, right? That's why I'm giving. Okay, let's say you have, okay, sorry. Let's say you have this kind of truth table. Yeah, you have A, B, Z, and output. And let's say your output's like 0, 0, 0, 1, 0, 1, 0. Sorry, 0, 1, 0, and 1. Then 0, 0, 1, 1, 0, 0, 1, 1. 4 zeros, 4 ones. This is again very similar to the number systems. When you're filling that, this is the easiest way to fill the combinations. There's a pattern, right? There's a pattern when filling this. 0, 1, 0, 1, 0, 1, 0, 1, then 0, 0, 1, 1, 0, 0, 1. Then 4 zeros, 4 ones, 4 zeros, 4 ones. Okay, let's say the output is this. Sorry. Let's tell the output is this. You have 0, 0, 0, 0, 1, 0, 1. So can you tell me the circuit? What is the circuit that you're going to have? The easiest one is if you go for AND. Why? You have two ones, ne? One තියෙනවා නම් අඩුවෙන් go for the AND gate. So now tell me, you have two ones, no? So what is the output? What is the final output of this? A
plus B
and
and C.
A and
Yeah, sorry.
think about AND gate. AND gate will output 1 if and only if all are 1. So if you have all A, B, C 1, will it output 1 here?
Yes.
Yes, here you have 0. A, B, C 1.
No.
That 0 you have to convert, no? Understood?
Yes.
1, 0, 1. You had 1, 0, 1. And here B is 0. 0 will not give 1, no? Because AND gate logic is if all are 1, it is 1. If all inputs are 1, this is 1. That is the AND logic. Understood?
Yes.
Right? Here you have 0. That 0 you have to convert. How to convert? You add a NOT gate. Understood or not?
Yes, understood.
Okay, second one.
All three are A and B and C.
It's A and B and C. So this is the circuit.
Yeah.
So one is A, B, not C. The second one is A. So maybe you can simplify this. So you can simplify the circuit, right? Because in both you have A and C, ne? A and C in both. So you can write AC, you can take AC out, right? Because AC, both are there. You can see A and C out. Then you can write B naught or B. That is the remaining part, B naught and O B. So when you have B naught or B, yes, when you have B naught or B, it's, what is the value of B naught or B?
B.
B naught is 0 and B is 1, then it is 1. If B is B naught is 1 and B is 0, it is also 1. It's always 1.
Yeah.
Then this will
Yes.
be A, C, and within bracket 1, AC 1 means it is AC. So this is simplified version of this circuit.
Yes.
Simplified, you have A and C. If A and C both are 1, this will output 1. Here C, A, C both are not 1. No, 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 no. Here A and C both are 1, it's 1. A and C both 1, no. Here A and C both are 1, it's 1. Understood?
Yes, sir.
Right, okay. Right, okay. So if you want, you can write down, right? So if you want anything important, if you feel that is there anything important, you can write down, or can you remember? Oh, you're going to
Yes,
write.
sir.
You can remember, no?
Yeah.
Okay, good. Now you should be able to answer any kind of logic gate question, right? I did this very short lesson for logic gates, but even though it's very short, so I have highlighted very important things. That is the AND logic, OR logic. AND logic is if all are 1, it's 1. OR logic is if all are 0, it's 0. Not logic is inversion. And using that, you can write you can write in answers to any question. That is the magic. If you have NAND, can you quickly draw a truth table for NAND? NAND. NAND means what? NAND means A and B both are there and both will be going through a NOT gate, no?
Yes.
So you know the AND logic. AND logic is what? 1, 1 equal 1. Then what is the NAND logic? 1, 1 equal
0.
0 is the NAND logic. All other occurrences. So no need to actually even think all other occurrences. All other occurrences mean 0, 1, 0, 0 will be 1, 0, 1 will be 1, 1, 0 will be 1. So that's the NAND logic. This is when you NAND, right? NAND means you have to NOT this. And you have to bracket and NOT. So likewise, you can generate any kind of circuit, NAND, NOR, any kind of thing you can generate using this. Okay?
Yes.
Right. And if you are given an AND gate and asked create this kind of circuit, so this can go further, right? If you are given NAND gate and asking in the exam, you are given NAND gate. NAND gate and asking you to create this circuit A, B, and you have output, and you have here you have so like 1, 1, 0, 0. Here you have, let's say 0, 1, 0, 1. The better way of writing this is 0, 0, 1, 1. That is the ordered way of writing this. And you have to use NAND gate, right? You have to use NAND gate to get this output. Can you write this 1, 1, 0, 0? You have to use NAND gate to get this output. Only NAND gate. Can you do this? Try to do this alone. Draw the circuit using NAND gate. Now let's see these logical operators. So we learned these things. Basically in Pascal, the arithmetic operators, division, modulus. Division is basically the integer number and the remainder is modulus. And the not equal operator. And then the logical and means if all are true, it's true. Or means if all are false, here all are false, it's false. That is all logic. And not logic means simply the reverse.
Yes.
And operator precedence is given because not is unary. Not is unary means it applicable on just for single thing. Here, not is unary. So it is given the first preference. Then the multiplication, division, then division, modulus, and AND operator. Then addition, subtraction, and OR operator. This is how the precedence is given in the comparisons. Right, okay. Then, so they have given some examples to evaluate. So what will happen first? Here, what will happen first? The mod will happen first because modulus has higher precedence. Here, 14 mod 4 is 2 and 5 plus 2 is 7. Here, what will happen first? Division will happen first. 7 division 2 is 3, integer value, and 3 plus 3 is 6. Here, what will happen first?
Multiplication.
No,
sorry, division and then.
Yeah. So if you have same level operators, here multiplication, division, and all same level operators, it will go from left to right, right?
Yeah.
So you can do right to left, that is also okay. But normally, if both all are in same level, it will be evaluated left to right. So first it will divide 16 by 4, and it's 4. 4 into 2 is 8. Or you can write the other way. 4 into 2 is 8, and 16 divided by 8 is what?
2.
2. Is it correct or wrong? Then it's wrong. So basically, it's happened from it happens from this direction to the other direction. That means left to right, left to right. If it is same level, left to right. This one, the brackets. So here it has not mentioned. The bracket will be given the higher priority, and then in the bracket first it will consider 8 mod 2. 8 mod 2 is 0. Basically, haritam bedenavani. Then 0 is it greater than 5? No, it's false. Then false will be converted back, and that is true. Here you have two logics. First, it will be treated the bracket. Consider the bracket. And bracket will be evaluated first. 7 rate, no, it's false. And here this is next. 4 is greater than, yes, it is true, it is equal. And this not false, then it will be evaluated. Not false means true. True and true is true. Understood?
Yes, sir.
Okay. So then we discuss about this structure of program. And if you have, so we have not given this input output, but if you wish, you can give input and output part. Even without that, it will work. So basically, if this program has both input and output, better mention that. Then the declaring of the variable and begin and end, in between begin and end, you have to write the code. And comments basically you put inside. So curly braces, you put comment, and there's another way to do the comment, and this is also to write comment. This one can also be used. So for an example, let me go back, and this one here. If you want to write a comment, you can do it. So they recommend this method too. This is also valid comment, and this is also valid comment. Both methods are valid comments. Okay, so comments will be ignored by the compiler. Comments are just used to explain what's happening in the program or write maybe more details about the program that will be ignored by the compiler. Understood?
Yes.
Then in write and write-ln, we discuss the difference between write and write-ln. And then the selection, if-else statements, if-else, and here if then and if this one, the multiple if-else statements. If, then, else, and if. This one also we discuss, and multiple if-else statement. If you have multiple like this, how to write the code? Can you write? Okay. So can you convert this to, no need to convert this to pseudocode. Try to convert this to Pascal code quickly. Write the Pascal code for this one. Looking at this flowchart, try to write the Pascal code. So, but the basic is, yeah, you can just write it in the real compile and see, you know. So you got the output.
Yes, sir.
All right, then it's okay. Then take a print screen if you have done. So it's that's easy because this is the code. So given, they have given integer and then the character to treat. So I think you have you used character or anything else? String. When you are writing string, yeah, it's okay. You can use a string or character, anything. So yeah, let me go and write. Start get marks, and you're going to input the marks. Then M is the basically M is marks, and result is based on this one. You have 4 ifs, if. So above 75, above 65, above 50, and above 35. Okay. So let's write the code and the variables basically. So what are the variables? You can write character, whatever, right? That's okay. And variables are, one is I'm going to use the same thing, M for marks, and A for M. Yeah, M is enough. M is integer, and then you can say the next one is yeah, grade or marks. Result is char or character. Then begin. So in the code you can write, yes, you can just first input that. Write, is there any message? Get marks, maybe enter marks, and save the mark to read it to M. Then you have to decide based on that. If this M greater than or equal to 75, then result is A. Then how to write the next one? Else if, yes.
Else if
M greater than or equal to,
M greater than equal to 65.
65, then
result equal B.
Result equal B, okay.
And else else if M greater than or equal to 50.
50.
Yeah. Then result equals C.
C. as if m
else
greater
if
than
m greater than or equal to 35,
35. Yeah. Then
result equal s,
else
else result equal f.
this all. Then finally, what you have to do, we have to print the results. Yeah. Right. Right ln.
Bracket.
You can see result is result. That's all. So just run this. Okay, any error is there? Yeah, there's an error. What's that?
So the word
Huh?
the right ln you typed it wrong, I guess.
This one.
Yeah.
But there is not an error. So here it highlight the ninth one. 9.5. Maybe you can just ignore this because it's only one line. Right. When there's one line, no need to give the semicolon because you can give that in the last one because it is what end in the statement. If it is continuous, if that will be ended with this one. Right. Let me give 67. So that's why I asked you to practice. Then result is B. So let me run this again. Let's give 76. Result is A. Let's run it again. And then let's say enter some number like 25 or 45, 25. Says result is F. Okay, you're getting. So that's why I asked you to write in the real compiler rather than just write in the book. So you can copy this, right? You wrote in here or you wrote in book?
So I wrote it in the compiler and I I backed up. I didn't save it.
You didn't say it, right? You didn't run it? You can.
I did.
No, you didn't. Right, okay. So that's why this semicolon part also. So these things, these minor things, but it's still here. They have break down this and given, but it's not required. You can just write the same line, right? So here they have give if this one read is else if it is given the next line, but no need to give that. You can give in the same line. Else if,
Yes.
right? And this is where using switch and case, right? So this is where switch and case is used here. So the second one, switch case. So basically, in switch case, the same if else can be given using switch case, the second method. In the second method, you have to give the range, exact case. Here you give the same inputs, marks and grade, then enter the marks, then case of. Case marks means this marks, case marks of, then you give the range. 0, double dot, 34 means 0 and 34 in between, including 0 and 34, right? 0, 34, it's W. 35, 49 says 50, 64, it's C. And 65, 74, it's B. And 75 to 100, it's A. So this is another way of writing this. This is actually the Pascal program. Okay, pseudocode, they have not given the pseudocode, but pseudocode, you can write the same. So no need to write Y, you can just say begin and end. In between that, you can just write the same. And this is the Pascal program to implement switch case. And this is the second one. I said that in the beginning also I said, so same thing you can implement using switch case. Okay, so since that is there in the book page number 29, I'm not going to repeat this again. But you know the places with which we have users. So switch case can be used just for comparing one thing, right? So just to this
Yes.
related to marks, you can give the cases. These are the cases available for marks. Right, if it is like odd even, can you, okay. So please write a question. Please write a question. Use case statement in Pascal and create a program to print whether the number is odd or even by looping through the first 20 integers from 0 to 20. Use case statement in Pascal to create a program to print whether the number is odd or even. So you have to print whether the number is odd or even, and by looping through the first 20 integers, that means 0 to 20. So you can just go 0, 1, 2, 3, 4, 5, 6, up to 20. And you have to print in front of the number, you have to print whether the number is odd or even. But you have to use switch and case, not if else. Switch case. Okay, so I'll keep this as homework. What you can do is after completing, you can send it to me as a screenshot, or maybe take a photo of this and send it to me. Do this in the compiler, right? Real compiler, don't do in book. After getting the correct answer, you can write it in the book. Do it practically, because you know the practical thing, so it give you more exposure, no? So I don't know whether you have done the practicals in school. Sometimes we have done. Some students, they don't prefer, so they like to read the book and study the book and keep that in mind without practicing the code. But that is not good for a subject like IT. It's really not good, because so you know, after we did practicals, it confirms your brain that this is the code, right? Because you have experience, you have exposure to the program. Isn't that so? ඒක එහෙමද නැද්ද මන් දන්නේ මං කියන හින්දා yes කියන්න එපා. So you think and tell me. So have you done practicals before? දැන් ඔයා programming අමාරු කියලා කිව්වනේ. Have you done practicals before?
So in programming?
Yeah.
No, sir.
You have not done. So maybe you didn't have time to do in the practicals, maybe in the school, because it's almost closed, no? Last year, this year.
Yes, sir.
Right. But if you do the practical, what will happen? There will be a significant change in this, no? So Photoshop
Yes,
also same. You know the HTML and Photoshop. Have you done practicals for HTML, Photoshop, those things?
Yes, sir. We did those in school.
Oh, those in school. So when you do practicals, it confirms. That is the nature of IT. So, but don't try to just go and read the book and study and remember the things. That's not going to help, because then you don't need for the examination. For example, for the examination, do you need to study this again? Or can you write down? It's in your memory, no?
Yes, sir.
මං හිතන්නේ ආයෙ මේක ස්ටඩි කරලා බලලා පාඩම් කරලා යන්න ඕන කියලා. So when is your exam date exactly?
So they said it was in the first week of March, but not like they didn't really give a date.
No? Not confirmed, right?
Yeah.
Okay. Not confirmed. The exam schedule is not yet published, no? Have you seen?
No, sir.
You can just go and see donets.lk. Sometimes it might be published. Still, I think it's to be decided. Okay.
Yes.
Right. Then, so anyway, so this one, you don't no need to study now. So I think the studying is also completed. Chapter is also completed, lesson is also completed, activity is completed, studying also completed. Now what you have to do? You have to practice. Practice the papers. Go through the papers and try to answer the questions in the paper. Right? Then so next day I'll discuss few questions too. in the papers referring to the past papers, but any paper you can find the question. No, in MCQ also you will get a question from this, one or two question, not more than one or two questions you will get from MCQ part, and structured and semi-structured. So structured and essay also you are getting questions.
Yes.
Right. So please go through those and let me know if you have any difficulties to understand the question. And okay, let's move down. And next you have this for loop. So for is basically, it's very easy, right? The for loop is very easy here. So you have to tell the starting position and ending position, and then no need to actually increment or add one. Likewise, no need to do that. You can tell the starting position, ending position, and that will simply loop through that. So here, this is another way. So if you want to go from 1 to 10, you can write like this, but 10 to 1 also it's possible. Then you have to use down to. Yeah, 1 to 2 do, but if you are going the other way, you have to say 10 down to 5 do, right? Or 4 down to 0, 2. So 4 down to 0 means 4 to the 0. So 4, 3, 2. So altogether it's 5 occurrences. 10 down to 5 means including 10 and 5, 10 to the 5. It's 10 minus 5 is 5 plus 1 is 6. 6 repetitions because including 10 and 5. And here, this is an example for I 1 to 2, 1 to 10 to write in the number, read number, and then so you are totally in the particular number and find the. So this is what this program does. Can you explain what this program does? By reading the program?
Sorry, sir, what was it?
So what this program is intended to do? So what kind of output from this one?
To find the total of some given numbers and the average.
Yeah, how many numbers? Will count
10 numbers.
Yeah, it will let us input 10 numbers. It will read those 10 numbers and continuously adding that to the total. And after this repetition, you can find the total of all 10 numbers as well as average of those 10 numbers. Right?
Yes.
It's clear, no?
Yeah.
Then, so do while loop, we did that. That is the easiest one. And the repeat until. Repeat until loop and the do while loop. The difference is repeat until loop start doing this without checking the condition. It's like you jump to the river and then you check whether you can swim. So, but while loop, first, before jumping to the river, it check whether you can swim and then jump to the river. So that is the difference. So sometimes you need this one. So why? Because when you start downloading software, you just start downloading without worrying. You just start downloading. In the middle space is not enough. Then the browser or this downloading program will inform you, please, your hard disk or disk space is not enough. Please clean some files to continue the download. Right?
Yes.
When installing a software, what will happen? When installing a software, it will start the installing. But in the middle, if it found that space is not enough or some other error, it will roll back. Right? But anyway, it will start. When copying file, it will start copying files. But in the middle, it will say some space, you need some more space to copy the remaining files. When deleting files, it will start deleting the files. But after some time, it will found some files cannot be deleted. Some files cannot be deleted. Then it will inform us, these files cannot be deleted, what to do with this.
Yes.
So that is the fastest way, no? So when you ask some, but it is not safest, but that is the fastest. If you want to start the program without worrying about the conditions, you go for repeat until loop. You start doing this. Repeat, start writing Pascal, and then count is 1. Then only you check whether this condition is there. So here, this will print from 1 to, yes?
1 to 5.
1 to 5 or Pascal?
Pascal.
Yes. It will print Pascal. How many times it will print Pascal?
5 times.
Starting from 0.
Then 6 times.
6, no? Starting from 0.
Yes.
0th time plus 1. First time 2, 3, 4. 0, 1, 2, 3, 4, 5. 5, when it comes to 5, 5 is greater than 5? No. So then it will terminate. That means it will go to 0, 0, then 1, 2, 3, 4, and just 5. After that, it will check. Right? It will check whether this condition is met. Right? So
Yes.
loop. So when here the statement start in value 0, word Pascal is displayed in the screen. 1 will be added and check whether the count variable is larger than 5. So if loop is executed until the value of count variable become 5, right? But when value is 6, it will terminate. Because 6 greater than 5, yes, then it terminates. It will do 6 times. Right? Here, Pascal is displayed 6 times on the string. You understood correctly. And this is
Yes.
another one. So what's the output of this one?
The sum of like 50, 49 numbers less than 50.
Until sum less than 50.
50.
Then what will happen?
Oh.
What will be printed? First it will print sum is 0. Sum is sum plus 5. First it will print 5. Then it will check 5 less than 50. Is it true?
Yes.
Then what will happen?
And then it will add another 5 again.
It will add 5 over here. When 6 was less, 6 greater than 5, it stopped. When 6 greater than 5, it stops. So when condition is true, it stopped. Here, when 5 less than 50, what will happen? It should stop, no?
Yeah. So, but repeat.
Yeah, he also repeat until. Repeat until the condition is true. Repeat and repeat. The first time this is 1. 1 is not greater than 5. Condition is not true. So it repeat again. Then again check the condition. 2. 2 is not greater than 5. It will repeat again. Likewise, it will go 5. 5 is not greater than 5. It will repeat again. Now it will become 6. 6 is greater than 5. So it will terminate. So here also 5 will be added. Print that. And 5 is less than 50. Yes. Then it will terminate. So it will print only one time and it will terminate. So here the starting value is variable is 0, 5 is added to the value. Then sum 5 will be displayed in the screen. Check whether the sum variable less than 50. Yes, it is satisfied, so stopped. But it will print one time. 5 will be printed and then terminated. Understood or not?
Understood.
Right. It's going other way, right? If condition is true, it will stop. Not like while. If condition is true, it will stop. Okay, so I think with that we have discussed about these while nested controls and all repetition inside selection. So these things we discussed actually. Selection inside repetition, repetition inside selection. And just these parts we discussed. And one thing left, it is arrays. Arrays. And after that, arrays and the subprograms. I think we can finish it within next day. This part is theory. So arrays and subprograms, it's easy. Need of programming language, we discussed this actually. We discussed this actually, the machine language, assembly language, and higher level language. I'll discuss again if you cannot remember the stuff. And that is the end of the particular chapter. This is the end of the particular chapter. Then you have the concept of information systems and system development lifecycle. Okay, next week we will finish the lesson, right? Next week, or if you have another day in this week, we can finish the lesson. So next we can directly discuss the papers. Any doubts?
No, sir.
Right. Okay, then let's wind up for today. Okay.
Sir,
Yeah.
Ammi asked the fees for like the 4 classes.
Right.